Hello coders, I welcome you all. In this video, we are going to discuss our next machine learning project, mushroom classification using machine learning. The main objective of this project is to correctly classify if mushroom is edible or poisonous by its specifications like cap shape, cap color, gill color, etc. using different classifiers. We are going to use real-world dataset available on Kaggle. You can download this dataset from Kaggle or from my GitHub account. Link is given in the description of this video. So let's get started. As you can see here, to explain you this project, here I have mentioned some questions. So now let's solve them one by one. Before that, we have to import our dataset. So for that, let me import pandas as PD. Let me execute this cell. So as you can see here, our pandas library is successfully imported. So now let's load our dataset. So for that, let me write pd dot read underscore csv because our dataset is available in .csv file format with name mushrooms.csv. Let me store into one variable is equal to this statement. Let me execute this cell. As you can see over here, now our dataset is successfully loaded as pandas data frame. So now our first question. So in this question, we have to display top 5 rows of the dataset. So for that, let me write data which is pointing to our data frame. Here dot, we have to use head method of pandas data frame. Let me execute this cell. As you can see over here, by default, this head method is displaying top 5 rows of the dataset that you can see over here. As you can see here, some dots, because in our dataset we are having many columns, so we can't see each and every columns. If we want to see each and every columns, then we have to set one parameter. Let me show you this. So for that, we have to write pd dot set underscore option, and here we have to write display dot max underscore columns, and here we have to pass none. Let me execute this cell. Now let me execute this cell once again. As you can see here, now we can see each and every columns that you can see over here. So as you can see here, in our dataset, each and every columns have categorical data that you can see over here. And this is our target column class having two values, E and P, that you can see over here. E means edible, P means poisonous, that you can see over here. So you can refer this cell to get meaning of particular character in the particular column that you can see over here. Let me take another column, cap shape. As you can see here, in this cap shape, B means bell, C means conical, X means convex, F means flat, K means knob, S means sunken, that you can see over here. So by using this cell, you can get meaning of particular character in the particular column. So this way we can display top 5 rows of the dataset using head method of pandas data frame. So now our next question. In this question, we have to check last 5 rows of the dataset. So for that, we have to use tail method of pandas data frame. Let me execute this cell. As you can see here, by default, tail method is displaying last 5 rows of the dataset that you can see over here. By this, we can able to see total how many rows are available in our dataset that you can see over here. So this way we can check last 5 rows of the dataset using tail method of pandas data frame that you can see over here. So now our next question. In this question, we have to find shape of our dataset, means number of rows and number of columns available in our dataset. So for that, we have to use shape attribute of pandas data frame. Please remember, shape is not a method. It is an attribute of pandas data frame. Let me execute this cell. As you can see here, output is Python tuple. This is at index 0 and this is at index 1. Let me print it in proper format using this print function. Let me write number of rows data dot shape index 0, this one, and let me write print number of columns data dot shape index 1, this one. Let me execute this cell. As you can see here, in our dataset total we are having this many rows. In our dataset total we are having this many columns that you can see over here. So this way we can find shape of our dataset, means number of rows and number of columns available in our dataset using shape attribute of pandas data frame that you can see over here. So now our next question. In this question, we have to get information about our dataset like total number of rows, total number of columns, data types of each column, and memory requirement that we can do with just one method, info method of pandas data frame. Let me execute this cell. As you can see over here, in our dataset total we are having this many rows with this indexes. Total we are having this many columns. As you can see here, column names. available in our dataset, and no null count. Means in our dataset, total we are having this many non-null values in this particular column, this many non-null values in this particular column, this many non-null values in this particular column. Likewise, as you can see here, d type, data type for each and every columns that you can see over here. As you can see here, d types colon means in our dataset total we are having 23 columns with object data type, and as you can see here, memory usage for our data set. So this way we can get information about our data set like total number of rows, total number of columns, data types of each column, and memory requirement using info method of pandas data frame that you can see over here. So now our next question. So in this question we have to check null values in our data set. So for that we have to write data and we have to use is null method of pandas data frame. Let me execute this cell. As you can see over here, now it is displaying pandas data frame with boolean values that you can see over here. So let's find sum of true values using this sum function. Let me execute this cell. As you can see over here, so looking at the output, we can see that we are fortunate this time because there is no any null value in our data set that you can see over here. So this way we can check null values in the data set that you can see over here. So now our next question. In this question, we have to get overall statistics about our data set. So for that, we have to use describe method of pandas data frame. Let me execute this cell. As you can see over here, the describe method give you the statistics of the columns that you can see over here. Count shows the number of responses available in this particular column. This unique shows the number of unique categorical values in this particular column, in this particular column, in this particular column. Likewise, as you can see here, this top shows the highest occurring categorical value in this particular column. Likewise, as you can see here, this frequency shows the frequency of the highest occurring value in this particular column. So this way we can get overall statistics about our dataset using describe method of pandas data frame that you can see over here. So now our next question. Here in this question we are going to perform data manipulation. So now let me check top 5 rows of our dataset using head method of pandas data frame. As you can see here, our dataset contains columns with categorical values that you can see over here. So we have to convert these categorical values into numerical values because machine learning algorithms can understand only numerical values. So for this, we are going to use label encoder. So this label encoder converts each and every value in this column to a number. But this approach requires categorical column to be of categorical data type. So let me write data.info. As you can see here, as I said, our dataset contains 23 columns with object data type. As I said, this approach requires categorical column to be of categorical data type, but we are having this object data type. So please remember, by default, a non-numerical column is represented by object data type that you can see over here. So let's first convert our columns data type to category so we can use label encoder. So for that, let me write data.astype. And here let me write category and let me assign back to modify our existing data frame. Let me execute this cell. Let me check. Let me write data.dtypes. Also we can use this info method. As you can see here, now we have successfully converted the columns to be of categorical type. So we can use label encoder to make columns into machine understandable format, means into numerical format. So now let's do this. Now let's use label encoder. So for that, first we have to import from sklearn.preprocessing. We have to import label encoder, and let me create instance of this label encoder. SLE is equal to this statement. Now we are going to apply this label encoder on each and every columns. So for that we have to use for loop for column in data.columns, each and every columns, and let me write le.fit_transform and data, which is pointing to our data frame, and here we have to pass this variable column, and to modify our existing data frame we have to assign back is equal to this statement. Let me execute this cell. Let me check top 5 rows of our data set. As you can see over here, now our column values are converted into numerical format. So this way we can use label encoder to convert categorical values into numerical values that you can see over here. Now our next question. In this question we are going to store our feature matrix means our independent variables in X, and we are going to store our response variable, also called as a target variable, or dependent variable in vector Y. So let me write X is equal to data dot drop. So let me drop our target variable class, and here we have to write access is equal to 1, and let me store our target variable, also called as a response or dependent variable, in vector Y. So let me pass our target variable into bracket notation, data and class. Let me execute cell. Let me check. As you can see over here, now our independent variables are available in matrix X, that you can see over here. Let me check why. As you can see here, now our response variable, also called as a target or dependent variable, available in vector Y, that you can see over here. So this way we can store our feature matrix in X, means our independent variables in X, and this way we can store our response variable or target variable or dependent variable in vector Y, that you can see over here. Now our next question. In this question, we are going to apply PCA, Principal Component Analysis. As you know, our dataset contains many columns, right? But we can remove the highly correlated columns. So our dataset becomes smaller in size and still holds most of the information. To do this, we can use PCA. So what is PCA? Principal Component Analysis, or PCA, is a dimensionality reduction technique that is often used to reduce the dimensionality of the large data sets by transforming a large set of variables into a smaller one that still contains most of the information in the large data set. Please remember, the idea of PCA is simple. Reduce the number of variables of a data set while preserving as much information as possible. That's all. Please remember, when you give a PCA model a sample with input features, the output of PCA model is a completely new set of features. Suppose when you give 23 features which is available in our dataset to PCA, it will produce new features like component 0, component 1, likewise. Right? So you might be wondering what exactly the PCA is doing. Please remember, with PCA, we can capture whatever information represented by these 23 columns available in our dataset. We can represent same information with less number of columns. Why is this important? As you know, model training is very computationally intensive process. Fewer features, typically less resources needed for training. That's why we are using PCA. So now let's apply PCA. So for that, let me import from sklearn.decomposition. We have to import PCA. Let me create instance of PCA, and here we can pass n underscore components. Let me pass 7. You may try with different numbers, and let me create one variable. PCA1 is equal to this statement. You can use n, and let me write PCA1 dot fit underscore transform, and here let me pass our independent variables available inside X, and let me assign it to one variable. PCA fit is equal to this statement. You can use any. Let me execute this cell. Let me write PCA1 dot explain underscore variance underscore ratio. Let me execute this cell. As you can see over here, 7 components. So as we discussed, when you give 23 features available in our dataset to PCA, it will produce new features like component 0, component 1, likewise. So here PCA has produced 7 components because here we have passed 7. So now the question is, how much dimension reduction is possible with PCA? So answer to this is, PCA implementation allows you to specify number of components you want, that we have passed over here, 7, or let PCA figure it out. So in this case, you need to tell PCA how much information it needs to retain as percentage. So here, suppose if you want to retain 90% of information, then here we can pass 0.90. But here we are going to pass number of components. Let me pass 7. You may try with different numbers. Let me execute this cell once again, and let me execute this cell once again. Let me create cell below. Let me copy this statement and let me use this sum function. Let me execute this cell. As you can see over here, output is 85. Means here we can say that 7 components retaining 85% of information from our data set. So this way we can use PCA for dimensionality reduction, that you can see over here. Now our next question. In this question, we are going to split our data set into the training set and the testing set to evaluate the performance of our machine learning models. So for that, let me import from sklearn.model underscore selection. We have to import train underscore test underscore split. Let me write train underscore test underscore split. And here we have to pass our independent variables that we have stored after PCA into PCA underscore fit. So here we have to pass PCA underscore fit and our dependent variable available in vector y. And I'm going to set test size to 0.20, means we are going to keep aside 20% data for testing purpose. And let me set random underscore state to 42, and let me assign this to x underscore train, x underscore test, y underscore train, and y underscore test is equal to this statement. Let me execute this cell. Let me check x underscore train, as you can see over here. Let me check y underscore that you can see over here. So now we have divided our data set into two sets, one for training and one for testing. So we are going to train our models on X train and Y train, and we will perform prediction using X test, our unseen samples, and we will compare our predicted result by our models with Y test. So this way we can split our data set into the training set and the testing set that you can see over here to evaluate the performance of our models that you can see over here. So now our next question. Here we are going to import different models. Now let me display top 5 rows of our data set. As you can see over here, this is our target variable class. Contains two values, 0 and 1. 1 means poisonous, 0 means edible. So we can see that our target variable is categorical. So this is classification problem. So we are going to import different classification models. So let me import from sklearn.linear underscore models. Let me import logistic regression from sklearn.neighbors. Let me import k-neighbors classifier from sklearn.svm. Let me import svc support vector classifier from sklearn.tree. Let me import decision tree classifier from sklearn.ensemble. Let me import random forest classifier from sklearn.ensemble. Let me import gradient boosting classifier. Let me execute this cell. As you can see over here, our models are successfully imported that you can see over here. So this way we can import different models that you can see over here. Now our next question. Here we are going to train our models that we have imported over here. So let me create instance of logistic regression as LR. So let me write LR.fit on our training set on X train and Y train. Let me create instance of k-neighbors classifier KNN. So let me write KNN.fit on X train and Y train on our training set. Let me create instance of SVC support vector classifier. Now let's train support vector classifier on our training set X train and Y train. Now let me create instance of decision tree classifier SDT. Now let's train decision tree classifier on our training set. Now let's create instance of random forest classifier SRM. Let's train random forest classifier on our training set. Now let's create instance of gradient boosting classifier SGB. Let's train gradient boosting classifier on our training set. Let me execute this cell. As you can see over here, now our models are successfully trained on our training set on X train and Y train. So this way we can perform model training using fit method that you can see over here. So now our next question. Here we are going to perform prediction on test data available inside X underscore test, means using our unseen samples. So let me write LR dot predict X underscore test, our unseen samples, and let's assign these predictions by logistic regression into ypred 1. Let me copy this statement and let me paste it over here, and let me change it to 2, 3, 4, 5 and 6. because here we have trained 6 models that you can see over here. And let me change to KNN for K-neighbors classifier, SVC support vector classifier, decision tree classifier, random forest classifier, gradient boosting classifier. Let me execute this cell. Now predictions are available inside these variables. So this way we can perform prediction on unseen samples, means on test data that you can see over here using this predict method. So now our next question. Here we are going to evaluate the performance of our model using accuracy score. So let me import from sklearn dot matrix. Let me import accuracy underscore score. Let me execute this cell. As you can see here, accuracy underscore score module is successfully imported. So let me write print accuracy score by logistic regression, and let me press shift tab over here to check log string of this accuracy underscore score method. As you can see here, we have to pass actual values and predicted values. So in our case, actual values are available inside y underscore test and predicted values by our models available inside y underscore pred 1 for logistic regression. Let me copy this statement and let me paste it over and let me change it to KNN for K-neighbors classifier, and predictions are available inside y underscore pred 2. Let me change it to 3, 4, 5 and let me change it to SVC support vector classifier, decision tree classifier, random forest classifier, gradient boosting classifier. Let me execute this cell. As you can see over here. So now let's visualize this so we can find our best model. So for that I am going to create pandas data frame. So pd.data frame. I am going to create this pandas data frame using Python dictionary. As a key, let me pass models. LR for logistic regression, K-neighbors classifier, support vector classifier, decision tree classifier, random forest classifier, and gradient boosting classifier. And let me create another key, act for accuracy, and in Python list let me pass accuracy underscore score, actual values and predicted values by our model. To get accuracy in percentage, let me multiply it by 100 and let me copy this to save our recording time and let me paste it over here and let me change it to 2, 3, 4, 5, 6. Let me execute this cell. As you can see over here, our pandas data frame. So now let's visualize this. So for that I am going to use Seaborn's bar plot. So for that let me import Seaborn as SNS. Let me execute this cell. As you can see over here, now our Seaborn library is successfully imported. So let me use sns.bar plot and here let me pass final underscore data. Let me assign this data frame to one variable. Final underscore data is equal to this statement. Let me execute this cell. Let me check. As you can see here, we have successfully stored our pandas data frame into this variable. And here, let me pass this column, models. Let me copy this. Let me paste it over here. And on y-axis, let me pass this column, accuracy. Let me execute it as you can see over here. So from this bar plot, we can see that random forest is the best model for this data set with accuracy of 99.81% that you can see over here. So we are going to use this random forest in our production that you can see over here. So now our next question. Here we are going to save our model. So again and again training is not required and we can perform prediction using this save model. So please remember we have used train test plane just to evaluate the performance of our models. But during production we have to train our best model on entire data set. So now let's train our best model random forest on entire data set. So as you can see here, we have stored our independent variables after applying PCA into PCA underscore fit and our dependent variables are available inside Y. So now let me create instance of our best model random forest classifier as RF underscore model. Now let's train our best model random forest classifier on our entire dataset. So after PCA, our independent variables are available inside PCA underscore fit. Dependent variables are available inside Y. Let me execute set. As you can see over here, now our best model random forest classifier is trained on entire dataset. So now let's save our model. So for that I am going to import joblib library. As you can see here, now joblib library is successfully imported. Now let me write joblib.dump and let me pass instance of our best model, this one. And here you can give any. Let me give mushroom underscore prediction. You can give any. Let me execute this cell. As you can see over here. So now our model is successfully saved with this. So in future we can perform prediction using this same model. Let me show you this. So let me write joblib.load, and here we have to pass this name that we have just saved, and let me assign to one variable model is equal to this statement. Let me execute this cell. As you can see here, now our model is successfully loaded. To perform prediction using this saved model, here I have passed 22 values because our dataset contains 22 features, means 22 independent variables. And as you can see, I have passed it into 2D list. Then I have performed ECA transform on these values before performing prediction. Let me execute this cell. Now let me check. As you can see over here, means with these features, mushroom is poisonous. Let me display it in proper format. So if P0 equal to 1, then let me print poisonous. If 0, then let me print edible. Let me execute this cell. As you can see over here, with these features, mushroom is poisonous. That you can see over here. So this way we can perform prediction using our saved model. And this way we can save our best model that you can see over here. Now our next question, GUI. So here I have created GUI for this project, mushroom prediction using machine learning, that you can see over here. So as you know, we have created this GUI from scratch for our previous projects. So you must be knowing this. So let me execute this cell and let me execute this cell as well. As you can see over here, our GUI. So now let's perform prediction using this GUI. So I am going to pass these values. So let me pass 5. As you can see over here, 5 means convex. 2, that you can see over here for each and every columns. 4, 1, 6, 1, 0, 1, 4, 0, 3, 2, 2, 7, 7, 0, 2, 1, 4, 2, 3, and 5. Here I have passed same value. Just for testing purpose, let me press this button. As you can see over here, same output that you can see over here. With these values, mushroom is poisonous, that you can see over here. So this way we can create GUI for our machine learning model. Hope you like this video. Please don't forget to subscribe this channel. If you like this video, smash that like button. Thank you very much for watching this video. Take care. Bye-bye. See you in the next video.